Now we take up problem 80 of your textbook. Now this is actually a small problem, not pretty big. A thin spherical shell of radius r lying on a rough horizontal surface. So it's a rough horizontal surface, and there is a thin spherical shell. The thin spherical shell of radius r. Thin spherical shell of radius r. And it is hit sharply and horizontally by a cube. Now, what is a cube? You have observed indoor games like billiard or snooker. You might have seen the player uses a wooden stick about 3 feet long, about 1 meter long wooden stick to hit the billiard or snooker ball, and the ball starts rolling. That is what is called cue. Now it is hit by a cue, and where should it be hit? Now let us say it is hit here by the cue. It is hit here by the cue. This is the cue. So that the shell does not slip. That means there will be pure rolling. There will be pure rolling in this direction. Obviously, you can try it at home. If you hit the ball too low, particularly if you hit the ball below the center, the ball will tend to roll, but it will also slip over the billiard board or the snooker board. Let us consider it is to be hit by hit above a height h above the center. Those who plays billiard or snooker, they all know that the ball has to be always hit above its center, right? And say it is hit by a force F. So we write this way, say the ball is to be hit h meter above the center of mass and with a force F. Of course, force F we don't have to find out. We have to find out only the value of H. Where is it to be hit? Right? Now, due to this rolling, the ball will start rolling in this direction. I make a dotted line, sphere, and as a result, its center ball is rolling, but its center of mass is moving forward. Say the center of mass has a velocity v, we call it v center of mass, and also it has got an acceleration a of the center of mass. acceleration A of the center of mass. These are the assumptions. And say the ball has a mass m. Say mass is equal to m. So mass m multiplied by acceleration of the center of mass ma will be equal to the force. No doubt in that. So F is equal to m. F is equal to m and acceleration of the center of mass. That is, from here we get acceleration of the center of mass is equal to F by m. That we get from the very, very basic of mechanics. Acceleration is equal to F by m. Now it rotates. It rotates due to the torque of the force, right? Torque of the force F. The ball rotates due to torque of force F, due to torque of force F. And what is this torque? Torque is equal to force F multiplied by h, is the distance, right? Also, torque is equal to, we know, torque is equal to I, that moment of inertia, into omega. Sorry, not I omega, torque is equal to I alpha. Torque is equal to I alpha, moment of inertia multiplied by the angular acceleration. Let's say this angular acceleration is alpha. Torque is equal to I. So I alpha is equal to F H. From here we get alpha is equal to F H by I. I is the moment of inertia. Now for pure rolling, because the condition is we have to find out that the shell does not slip, it only pure rolls. For pure rolling, I have said to you earlier, for pure rolling, V equal to R omega and alpha equal to RA. For pure rolling, alpha is equal to R. We have taken capital R or small r. Is given capital R. Alpha is equal to RA. That means angular acceleration is equal to radius of rotation multiplied by the linear acceleration. If that is so, what is alpha? Alpha equal to FH by I. Alpha equal to FH by I. And alpha is equal to FH by I. And acceleration we have found by Fm. So alpha is equal to Ra. So FH by I will be equal to, so sorry, I have made a mistake here. That's why I was getting confused. This is not alpha equal to Ra. It is A is equal to R alpha. A is equal to R. A we have already got, which is F by M. So F by M is equal to R into alpha we have got here F H by I. Therefore, H is equal to F equal to F equal to I by MR because F on both sides gets cancelled. So H equal to FH by I. So H is equal to I upon MR. So H is equal to I on the left hand side goes to the numerator I divided by MR. This is the value of H. Now, what is the value of I of a thin spherical shell? I or moment of inertia is 2 by 3 mr square. Is 2 by 3 mr square. That divided by AMR multiplied by 1 by AMR. So this R gets cancelled. We are left with only one R. M and M gets cancelled. So this is equal to by 3 R. That means the ball has to be hit by the cube at a point F where H is equal to this height is equal to 2R by 3 or 2/3 of the radius. So this problem was short and simple, no problem.